students. Attendance check. Is everyone here?
Yes, madam.
Okay, so before we begin, I would like to ask everyone to spare a minute of solitude to enjoin everyone to pray in their own respective faith. Okay, thank you very much. You may now take your seats and take out your notebooks and other instructional materials. Okay, so to jumpstart our discussion for today, let us have a buzz session. So this question is for everyone and you may discuss the answers with your seatmate. So the question is, what goes into your mind when you hear the word periodic? You have 1 minute to discuss with your pair, and then afterwards, I would like you to share with the class what transfers in your discussion.
A few moments later.
Okay, so your 1 minute is up. Let's hear what you have to say. So what words do you associate with the word periodic? Yes.
Mom, I think of the periodic table when I hear the word periodic.
Okay, thank you. So let me write that down. Periodic table. So what else?
Mine is periodical tests.
Periodical tests. So let's also write it down. Thank you. Any other answers?
Menstruation, Mom.
Menstruation. Thank you. Let's also write it down. Okay, so what common ideas exist between these words that we have written? So in what context was the word periodic used in these terms or phrases?
Well, in the periodic table, the elements are arranged in periods.
Okay, so what do you notice with elements of same periods in the periodic table of elements?
There is a recurring pattern called the periodic law in their properties. In the context of chemistry and the periodic table, periodicity refers to trends or recurring variations in element properties with increasing atomic number. Periodicity is caused by regular and predictable variations in element atomic structure.
So a recurring pattern. What about periodical tests?
Periodical tests are carried out every end of a quarter.
So how many times do you take a periodical test?
4 times a year. It is a recurring exam.
Okay, so this one's interesting, menstruation. Why associate it with the word periodic?
For the women, it happens every month.
So periodic basically means
Recurring?
Happening repeatedly.
Cyclic.
right. So what other things occur periodically? For example, in contemporary art. So let's look at examples in contemporary art of the Philippines. What are things that occur or appear periodically in contemporary Philippine arts.
Mom, the Sinulog Festival dance steps. 2 steps forward, 1 step backward.
Yes, that's one.
Madam, the triangular patterns in the 2021 quincentennial commemorations in the Philippines logo.
Yes, good observation. Now, aside from what we see in in contemporary arts, what other things occur periodically?
How about the motion of a pendulum, madam?
So yes, that's another good example. A pendulum's back and forth motion is a good example of periodic motion, or what we call oscillation. So any motion that repeats itself at regular intervals is called periodic motion, or harmonic motion. This kind of motion, called periodic motion or oscillation, is the subject of this chapter. Understanding periodic motion will be essential for our study of waves, sound, alternating electric currents, and light later. We are interested here in motion that repeats itself in a particular way, more specifically called simple harmonic motion. In this chapter, we will concentrate on one example of systems undergoing simple harmonic motion, and that is the spring mass system. Specifically, at the end of this lesson, we are hoping that you will be able to confidently say, I can recognize the necessary conditions for an object to undergo simple harmonic motion. I can calculate the period and the frequency of spring mass system. Now, to help us achieve these competencies, we have to look back on the following prerequisite concepts, which you were expected to have learned before we focus on our content standard. One cycle is a complete vibration. The period T is the time to complete one cycle. The SI unit is the second. The frequency F is the number of cycles in a unit of time. It is always positive. The angular frequency omega is 2 pi f. By the definition, period and frequency are reciprocals of each other. So in which previous topic were these concepts discussed?
Circular motion.
Right. Circular motion, correct. Now, in this institution, we would like our learners to be active participants in the learning journey, to construct their own knowledge and learnings, and integrate them with what they already know. So in line with that, let's get ready for our activity today. The title of the activity is Springtime. Okay? So I would like the group leaders to come here in front and obtain a copy of your activity guides and distribute them to your group members. Okay, so does everyone have a copy of the activity guide? Very well. So I would like to ask a volunteer to read the objectives of our activity today.
Determine the force constant of a spring. Calculate the slope of the line. Recognize the necessary conditions for an object to undergo simple harmonic motion for a spring mass system.
Okay, so you have to remember that the ultimate goal of our activity is for you to be able to recognize the necessary conditions for an object to undergo simple harmonic motion for a spring mass system. Now, in this activity, you will need the following materials. So, you need a Hooke'S Law apparatus. You need a set of slotted weights, a timer, a calculator, and of course, a graphing paper and a pencil. All these materials are ready for collection at your respective dispensing areas. So, group leaders, I would like you to facilitate the distribution of these materials to your respective team members. Before you begin your activity, I would like to give you 2 minutes to go over the instructions in your activity guides. After that, I'll ask you if you have any questions or clarifications.
A few moments later.
Since there are no questions or clarifications, you can now start performing your activities. Please remember that you're only given 30 minutes to accomplish this, after which a representative from each group will be asked to report the results of their activities. So here's what we expect students to do during the activity. This is your Hooke'S Law apparatus. It is already set up this way. Okay, so this is just a simple rod with an attached spring. It's removable. We also have this. Okay, so this is where you place your weights later. So before the activity, students have to make sure that the Hooke'S Law apparatus is set up on a level surface. So they have to check if the table where they're placing their Hooke'S Law apparatus is a level surface. So this is the attached ruler of your Hooke'S Law apparatus, and in this ruler, if you notice, there are two measurement systems. On the left side, you have the numbers 1 to 6 going down from top to bottom, and these numbers are in inches. On the right side, bottom up, you have the numbers 1 to 15, and these are in centimeters. So please do not be confused now which measurement system we will be using. So as a convention, what we will be using is the unit centimeters. So we will use the unit centimeters because our constants, which we will be using in our calculations later, are in meters. And it's more convenient to convert centimeters to meters rather than the inches to meters. So since the numbers on the right goes from the bottom part going up, you have the number 15 here on the top. What we will be doing is we will set the 15 to be our 0 mark. So when we measure later, always remember that 15 is our 0 mark. So 14 now becomes our 1 centimeter. 13 is our 2 centimeters. 12 is our 3 centimeters, and so on and so forth. So when you take your measurements later, make sure that your spring is stationary and not like this. So before you start measuring, your spring should not be moving. So we also have to make sure that the 0 part of our ruler, which is our 15 centimeter by convention, is aligned with the bottommost part of your spring. So the ruler is movable, so it requires So now we are ready to perform part A of our activity. So first, we attach one hanging mass to the end of the spring. So the first value is 100 grams. And then we measure the new length of the spring. So from the 15 mark, how much did it elongate? So this time we use a 300 gram weight and check the elongation. Again, when you record the new length or the elongation of the spring, it should not be oscillating like this. You have to wait until it stops moving so you can get an accurate measurement of the elongation of the spring. As the spring has now stopped oscillating, we can read the measurement. So the spring is elongated to about 5.5 centimeters. Finally, we have our 500 gram weight and record the elongation of your spring. So your spring elongated to about 8.5 centimeters. So we are now on part B of our activity. So this time we added 250 gram weight to our spring. And then we will pull it down by about 2 centimeters and then release. After that, we get the time taken by the mass to complete 20 vibrations. And then determine the period T by dividing the time by 20. We're going to make 3 trials and then solve for the average value of the period.
Good day. We're here to report the results of our activity. On the first column is force, and force is equal to mass times acceleration. Mass is in kilograms while acceleration is in meters per second squared. The unit of force is in newtons. The value of acceleration is the value of the acceleration due to gravity and is approximately 10 meters per second squared. Multiply it with the value of mass here. It should be converted from grams to kilograms. So from the given mass 100 grams, divide by a 1000 to convert to kilograms. Then, multiply by 10 meters per second squared to become a force quantity. We get 1 Newton. Do the same thing to the succeeding masses. The following are the data for our spring elongation. Graph the force versus displacement data. Displacement is the elongation of the spring.
Now to show the force versus displacement graph, we used Microsoft Excel. First highlight the data that you want to graph. Click Insert. Then Scatter Plot. The plot will be automatically inserted. Adjust the title and the axis labels. A good graph should contain these, including the units. Then right-click on any data point. Click on Trend Line. The default is linear. This is your best fit line. Display the linear equation.
The spring obeys Hooke's law. Hooke's law of elasticity is an approximation that states that the extension of a spring is directly proportional to the force applied to it. From its mathematical equation F is equal to negative kx, we got the spring constant, which is 0.0191 Newton per meter. Here we see a linear relationship between force and displacement. It shows here that one of the conditions for simple harmonic motion is when the restoring force is directly proportional to the displacement from equilibrium.
In Part A, we determined the spring constant graphically. In Part B, we determined the spring constant mathematically. First, we derived the spring constant from the equation for the period of a spring. The equation shows that the period and frequency of simple harmonic motion are completely determined by the mass m and the force constant k. In simple harmonic motion, the period and frequency do not depend on the amplitude a for given values of m and k. The time of one complete oscillation is the same whether the amplitude is large or small. One of the conditions for simple harmonic motion is that the frequency of oscillation does not depend on the amplitude.
What have you learned in our activities for today? So to guide you, here are the following questions that I would like you to answer. So first is, why is a spring mass system an example of simple harmonic motion?
Mass attached to a spring has frequencies of oscillation that are independent of amplitude. Also, it obeys Hooke's law, which occurs when the restoring force F is directly proportional to the displacement from equilibrium x.
Okay, very good. Describe the directions of the restoring force and displacement.
The restoring force must act opposite to the direction of motion.
Okay, well done. Next is, what does the minus sign in Hooke's law mean?
The minus sign means that, in simple harmonic motion, the acceleration and displacement always have opposite sides.
Okay, very good. Next is, what relationship exists between mass attached to a spring and its period of vibration?
The period of a spring mass system is proportional to the square root of the mass.
Very good. Okay, so let us apply what we have learned in our activities and in our discussion with a simple application problem. So I would like a volunteer to read our problem. So since you are a STEM medical class, our problem is anchored on a medical technology, which is the ultrasound. So the ultrasound uses a transducer applying the equations that we have just learned from our topic today. Alright, thank you very much. That's very good. And then finally we go to our assessment. Now this is a paper and pencil test. So I want you to grab a piece of paper and a ball pen or pencil, and of course your calculators. So you are given 30 minutes to answer the following questions. So letter A, what are the necessary conditions for an object to undergo simple harmonic motion? Letter B, answer the following problems and provide detailed solution. Again, always remember my instruction is every time you are to solve a word problem or a physics problem, you are required to explain your solution. So provide a detailed, step-by-step description of what you're doing in your solution. Especially the reasoning behind the steps that you did to arrive at the correct answer. So number 1, a spring takes 0.8 seconds to complete 4 cycles. What is the A, period, B, frequency, and C, angular frequency of the body? So you are required to answer 3 variables here, or 3 physical quantities. So the frequency, the period, and letter C, the angular frequency. Number 2, when a 2.5 kilogram object is suspended from a spring, the spring stretches by 0.05 meters. Letter A, what is the force constant? And letter B, if the suspended mass is set into vibration, what will be its frequency? So your 30 minutes begins now. Okay, so your 30 minutes is up. I would like to ask our class officers to collect our papers. I will be sending you feedback on your answers next meeting. So I will return your papers next meeting with detailed feedback on your responses. Okay, so to wrap up our discussion for today, let me leave you this statement. Be like a spring. Be like a spring. No matter how life pushes you back, you can always bounce back. And that is our quality of being resilient. So be resilient, be like a spring. So thank you very much and good day everyone.